All right, here we go. This is Unit 4 Trig test. Unit 4 Trig review. Page 4, part 2. There we go. That was something. All right. Write a sine and cosine function from the graph below. So let's see here. The first thing I notice is a sine function. Sine starts at our midline. I guess if I wanted to identify, here is our high point. Here is our low point. That means this one right here. That's kind of right in the middle. All right. So if we wanted to graph a sine function, starts at the midline, and then it also ends at the midline here. All right. So we're trying to write a sine function from this. So we know it's going to be f of x, or y equals whatever, equals, we need a, and then times the sine of bx plus c plus d. All right, we got to figure out a, b, and c, and d. First things first is d. D equals 0. There is no vertical shift. All right, what am I talking about? Yeah, there is. I take that back. D is 2. All right, it is getting shifted up 2 spots here. How high above 0 does it go? That is 2 units. All right. If we want to look here, I see this is a 6. This is at a -2. All right, what is the distance between these two? This is our amplitude. That has a distance of 4. So we know our amplitude is 4. Let's see here. The period, it starts at 0 and it ends at 6 pi. So our period equals 6 pi. All right. Well, we also know a period is equal to 2 pi over b. And that b value is what we are looking for. When we're graphing these things, we need to figure out a, b, c, and d. So this one is going to help us figure out the b value. So what we can say is we can say, all right, 6 pi equals 2 pi over b. Now, here's what I'm going to do. I'm going to go ahead and call this over 1. All right, so I have 2 fractions, and then we can cross multiply. It's like solving for any proportion. I'm going to say 6 pi times b equals 2 pi. All right, now I'm going to divide both sides by that 6 pi. And we're going to be left with our b value. B equals, all right, the pi's canceled, 2/6. That reduces down to 1/3. All right, so your b value is 1/3. The last thing we need to do is we need to figure out our phase shift. All right, how far to the left and how far to the right is this thing being pushed? Well, luckily, none, right? Normally it starts at 0 and it's still starting at 0. It's just being shifted up a little bit here. So that tells us right off the bat that the c value equals 0, right? So now we have everything we need. So we can plug it all in. So we can say f of x. F of x equals our a value here is 4, all right? But one thing I did forget to mention, this sine wave, it's upside down. All right, normally it starts at the middle and goes up. This time it's starting in the middle, it's going down. Right? So it's actually -4. Right? And then since it's a sine wave, I'm going to say the sine of b is 1/3. And we keep the x as an x. We said our c value is 0, so if you want to put a +0 here, you go ahead and do that. Right? You don't need it, but it's not hurting anything. And then the d value is 2. And there you go. That is our sine function here. If we were to graph this wave here, that is a sine graph. All right. Now the next one is they want us to go ahead and do the same thing, but find a cosine graph instead. So cosine, it starts and stops at its peaks, or in this case, its valleys. So this one is going to be a negative cosine value as well. All right, so we're going to have maybe g of x this time. I don't want to call this one f of x as well. So I'll say g of x equals a times the cosine of bx plus c, and then plus d. All right, so same thing. We need to find our values here. Luckily, our amplitude and our vertical shift stay the same. So I'm going to write those down right off the bat, right? It's the whole thing's moving up two spaces. The amplitude is 4. So I want to say the amplitude, or the a value, is 4. Our d value is 2. All right. The period is the same thing, right? So it starts at, if we want to look here, right, this value right here, this is 3 pi over 2. And it ends right here. That is 14, I think that's 15 pi. That's 15 pi over 2. If we subtract those, 15 minus 3 gives us 12. 12 pi over 2 leaves us with the 6 pi. All right, so our period is still 6 pi. So that means our b value also stays the same. All right, so I'm going to write that one. B equals 1/3. Right, that tells us our the length of our period. And the last thing we need to figure out is the d value. How far to the right does this thing get pushed? Right, so normally it starts at 0. How far over are they pushing this thing? And it looks like it's being pushed over 3 pi over 2. So our phase shift here, the phase shift is 3 pi over 2. Right? So now we need to figure out the c value associated with that. And of course, we know the phase shift to find the c value is negative c over b. Right? So plugging in everything we know b, we know the phase shift. I'm going to say 3 pi over 2 equals negative c over 1/3. And just like last time, cross multiply that and see what comes up. So we have negative 2c equals 1/3 times 3 pi. That is just pi. All right. Divide both sides by and negative 2. You're going to have c equals negative pi over 2. All right, there's your c value. So we have a, b, c, and now we have d. So we can say g of x equals, it is a negative, it was flipped upside down. All right, so just like the sine, how it was flipped upside down, the cosine is also flipped upside down. So we can say negative 4 cosine of 1/3 x, and then minus pi over 2, and then plus 2. And there we have it, right? If we were to graph both of those things, why don't you guys try that? Open up Desmos or something, or your graphing calculator. Graph these two functions, and you're going to see that they overlap, all right? So they're going to be right on top of each other. So there we go. This picture represented as a sine function and as a cosine function. All right, so that was the last part of your review. So hopefully that was good enough. If you guys have any more questions, just let me know.